Come with me on a journey. A journey not across the vastness of space, but into the deepest, most mysterious fabric of reality itself. We're going to a place where the familiar rules of our everyday world simply melt away. This is the realm of quantum physics. It's the science of the very, very small, the atoms, the electrons, the photons of light. Down here, things don't just exist in one place at one time. They can behave in ways that seem utterly impossible, like a ghost that can walk through walls, be in multiple rooms at once. It's a universe that operates on a completely different set of instructions, a hidden code that governs everything we see and touch, yet remains tantalizingly out of sight. One of the most mind-bending ideas in this realm is called superposition. Imagine spinning a coin. While it's in the air before it lands, is it heads or tails? In a way, it's both. A quantum particle like an electron can exist in a similar state of limbo, a blend of all its possible states at once. It's not here or there, it's here and there simultaneously. It's only when we look, when we measure it, that it chooses a single state, as if our very act of observation forces reality to make up its mind. Then there's an even stranger idea, one that Einstein famously called spooky action at a distance. It's called quantum entanglement. Now, let's return from the ghostly quantum realm to something a bit more familiar, yet no less revolutionary. Let's talk about a different kind of mind, not one born of biology, but one forged in silicon. This is artificial intelligence, or AI. At its heart, AI is the science of teaching computers to think, to learn to solve problems in ways that were once exclusively human. We've been dreaming of this for centuries, of creating beings that can reason and understand. Today, that dream is becoming reality, not as walking, talking robots, but as powerful software, reshaping our world. What does an AI actually do? It finds patterns. That's its superpower. Looking at millions of cat pictures to learn what a cat is. Analyzing complex financial data to predict market trends. AI is a master of recognition. It learns from experience just like we do, but on a scale and at a speed that is far beyond human capability. It can listen to our voices and understand our commands, translate languages in the blink of an eye, and even create breathtaking new art and music. AI is like a tireless, brilliant assistant that can sift through mountains of information to find the hidden gems of knowledge buried within. This matters because our world is now flooded with data. Every scientific experiment, every social media post, every medical scan, every star we photograph contributes to a digital ocean of information that is too vast for any human mind to navigate alone. We stand at a fascinating crossroads in human history. In one direction, we have the strange and boundless territory of quantum mechanics, the fundamental operating system of the cosmos. In the other, we have the rapidly evolving intelligence of AI, a powerful tool for deciphering complexity. What happens when we merge these two frontiers? We get something new, something with the potential to be far greater than the sum of its parts. This is the dawn of quantum AI. It's not just about making our current AI faster, it's about creating a fundamentally new type of intelligence, one that thinks in the language of the universe itself. Imagine an AI that doesn't just process information in a linear, step-by-step fashion. Imagine an AI that can embrace the quantum principles of superposition and entanglement. A quantum AI could hold multiple possibilities, multiple solutions, multiple lines of thought in its mind all at the same time. This is a radical departure from classical computers, which can only explore one path at a time. A quantum-powered AI could explore a vast landscape of potential answers simultaneously, like a million hikers searching a mountain range for a lost object at once, instead of a single hiker following one trail after another. This parallel processing power is the key to solving problems that are currently impossible for even the most powerful supercomputers. This partnership is a two-way street. Not only can quantum physics revolutionize AI, but AI can also help us finally make sense of quantum physics. The quantum world is notoriously difficult for our human brains to grasp. It's counterintuitive and buried in complex mathematics. An advanced AI could be the perfect translator. The implications are staggering. This fusion of quantum mechanics and artificial intelligence could represent the next great leap in our cosmic evolution. To understand the power of quantum AI, we first have to understand the revolutionary machine that will run it, the quantum computer. Your laptop, your phone, the most powerful supercomputers on Earth, they all think in bits. A bit is like a light switch. It can be on, it can be off, a 1, a 0. It's a simple, reliable system that has served us incredibly well, but it's also limited. To solve a complex problem, a classical computer has to try every combination of ones and zeros, one after another, which can take an eternity. It's like trying to find one specific grain of sand on a vast beach by inspecting each one individually. A quantum computer is fundamentally different. Instead of bits, it uses qubits. Thanks to the magic of superposition, a qubit is not just a 1 or a 0. It's a 1 and a 0 at the same time. By linking qubits together, 2 qubits can hold 4 states at once, 3 qubits can hold 8. 300 qubits could hold more states than there are atoms in the known universe. This is not just a small step improvement, it is an exponential leap in processing power, a change in the very nature of calculation. This incredible power comes from superposition and entanglement. Because the qubits exist in all possible states at once, the quantum computer can essentially test every single possible solution to a problem simultaneously. It's not checking the grains of sand one by one, it's looking at the entire beach in a single instant. For artificial intelligence, this is a game changer. This means we could create AIs that are vastly more complex, more nuanced, and more capable than anything we can currently build. The universe of quantum mechanics is, well, a universe of data. Every time physicists smash particles together in a collider or trap a single atom in a laser beam, they generate a torrent of information. This data is messy, filled with statistical noise and the inherent uncertainty of the quantum world. For 100 years, human scientists have been poring over this data, searching for clues, trying to piece together the puzzle of reality. We've made incredible progress, but honestly, we have this nagging feeling that we're only seeing part of the picture. Our human minds, with all their built-in biases and limited processing power, might be missing the most profound secrets. This is where AI can step in, not just as a mere calculator but as a new kind of scientist, a great detective for the quantum age. An AI can be trained on all the experimental data ever collected. It can learn the known laws of physics, quantum mechanics, relativity, and then search for deviations, for subtle patterns that don't quite fit. It can look at the data with completely fresh eyes, free from human intuition and preconceived notions about how the universe should work. An AI might find a correlation between two seemingly unrelated phenomena, a hidden symmetry, or a tiny inconsistency that points toward a deeper, more fundamental law of nature. Consider the search for a theory of everything, the holy grail of physics that would unite Einstein's theory of gravity with the weirdness of quantum mechanics. This is a problem that has stumped the greatest minds for generations. The mathematics are, honestly, incredibly complex, and the path forward is really unclear. An AI could explore mathematical landscapes that are just too vast and complex for any human to navigate. It could test thousands of hypothetical theories against the known data, discarding the ones that don't work and refining the ones that show promise. It could act as a tireless collaborator, suggesting new avenues of research and new experiments to run, guiding us toward the ultimate prize. Let's return to one of the most mind-stretching ideas in all of science, the many worlds interpretation of quantum mechanics. The idea that our universe is constantly splitting into countless parallel realities. For decades, this has been a fascinating but untestable hypothesis, a topic for philosophers more than experimental physicists. How could you ever prove that other universes exist if, by their very nature, they are separate from our own? This is where the convergence of quantum computing and artificial intelligence might offer a tantalizing, if speculative, new approach. We might not be able to visit another universe, but perhaps we could build one. A sufficiently powerful quantum computer guided by a sophisticated AI could create simulations of reality with unprecedented fidelity. A classical computer simulates a quantum system by laboriously calculating every possibility step by step. But a quantum computer is a quantum system. It could simulate the behavior of molecules, atoms, subatomic particles. The AI would act as the architect and director of this simulated world, setting the initial conditions, setting the fundamental laws, then letting the quantum simulation evolve on its own. It would be the closest thing we could create to a universe in a box. By running these simulations, we could explore the consequences of the many worlds theory. The AI could create a simulation of a quantum event with two possible outcomes. It could then follow the evolution of both branching universes inside the computer. By studying how these simulated realities evolve, and whether they could ever interact, we might find clues about the nature of our own reality. Could there be a faint leakage between universes? Could gravity be a force that extends across the multiverse? An AI could search for the mathematical signatures of such phenomena within its simulations, providing testable predictions for real-world experiments. This is, of course, highly speculative territory. We are a long way from simulating entire universes, but the principle is sound. AI-driven quantum simulation provides a new laboratory for exploring the most fundamental and philosophical questions about existence. It allows us to play with the very fabric of reality. To ask, what if? What if the laws of physics were slightly different? What if the universe had started with different conditions? By creating and studying these digital cousins of our own cosmos, we might finally begin to understand the deep logic behind why our universe is the way it is, and whether it is, in fact, the only one. The partnership of quantum physics and AI isn't just about exploring abstract theories or the far reaches of the cosmos. Its impact will be felt right here on Earth, in the very fabric of our daily lives, and even inside our own bodies. Take medicine, for example. Designing a new drug is incredibly difficult because it involves predicting how a complex molecule will interact with the equally complex proteins in our bodies. This is a quantum problem at its core, governed by the interactions of atoms and electrons. Classical computers can only approximate these interactions, but a quantum AI could simulate them perfectly. It could design personalized drugs, tailored to an individual's unique genetics, with incredible speed and accuracy. We are constantly searching for new materials, stronger and lighter alloys for aircraft, more efficient batteries for clean energy, superconductors that work at room temperature. Discovering these materials is often a slow process of trial and error. But a quantum AI could explore the almost infinite number of possible atomic combinations to design new materials from the ground up. It could predict a material's properties, its strength, its conductivity, its melting point, before it is ever created in a lab. This could spark a new industrial revolution, giving us materials that today seem like science fiction. In our increasingly digital world, cybersecurity is paramount. Much of our modern encryption relies on mathematical problems too hard for classical computers. But for a quantum computer, these problems are trivial. A powerful quantum computer could, in theory, break most of the encryption we use today to protect our bank accounts, government secrets, private communications. This is a serious threat. However, quantum AI can also be our greatest defense. It can help us design new quantum-proof encryption methods, creating a new generation of uncrackable codes based on the inherent uncertainty of quantum mechanics itself. And yes, let's not forget the cosmos. Planning a mission to Mars or a probe to a distant star is a monumental optimization problem. You have to calculate the perfect trajectory, manage fuel consumption, account for countless variables. A quantum AI could solve these problems with an elegance and efficiency we can only dream of today, opening up new possibilities for space exploration. It could also help us analyze the vast amounts of data streaming back from our telescopes, searching for the faint signal of an Earth-like planet around a distant star, or even for patterns that might suggest extraterrestrial intelligence. From our health to our security, to our place among the stars, this new technology will be a powerful engine of change. So, where does that leave us? Standing at the shore of a vast new cosmic ocean, we have the fundamental ghostly rules of the quantum world on one side, and the brilliant pattern-seeking power of artificial intelligence on the other. Their meeting is not a collision but a convergence, the creation of a new kind of compass, a new kind of ship to carry us into the unknown. The potential is undeniable, a future filled with discoveries we can barely imagine today. From understanding the first moments of the Big Bang to designing the very molecules of life, this technology could be the key. It's an invitation to a new odyssey of human exploration. This journey will not be without its challenges. The concerns about ethics, security, and control are real and must be taken seriously. We cannot stumble blindly into this new era. It requires a global conversation. Scientists, engineers, ethicists, artists, and citizens must all be part of charting the course. We need to build our ship thoughtfully, installing the necessary safeguards and ethical frameworks before we set sail. The goal is not just to build a powerful technology, but to build a wise one that reflects our best values and serves our highest aspirations for a better, more knowledgeable, and more humane future. Ultimately, the story of quantum AI is the story of curiosity. It's about our timeless, deeply human desire to understand the universe and our place within it. For millennia, we have looked up at the stars and asked the big questions. Where did we come from? Are we alone? What is the nature of reality? We've used our minds, our mathematics, and our telescopes to peer into the darkness. Now we are building a new kind of mind, one that speaks the universe's native quantum language to help us in that quest. It's a tool for asking bigger questions and perhaps for finally getting some answers. The cosmos is waiting. It is filled with more wonders than we have yet dreamed of. The convergence of quantum physics and artificial intelligence does not give us a destination, but it gives us a new way to travel, a new way to see. It's a continuation of the same journey we began when our ancestors first looked up at the night sky in awe. We are explorers, and the universe is our laboratory. With these powerful new tools in hand, we are ready to take the next step, to push the boundaries of knowledge, and to continue our grand space-time odyssey into the future.